Let's begin. So what we're going to discuss today is we're going to be talking about sign diagrams. I'm going to help build one with you today. All right. That way we can use that as we move forward. We're going to talk about the reciprocal function or rational function. We're not going to get to that today, but that's what we'll be doing Tuesday and Wednesday when we get back. So I'm going to connect the sign diagram with the quadratics that we've been doing the last couple of days. Okay. So you may go, I don't really need that today, but yes, but you will in the future, all right? Sometimes we don't want to be able to draw the whole graph. We just want to simply know when it's positive, when it's negative, when it's zero, when it's undefined, okay? So we want those features there. And in order to do that, we're going to construct a sign diagram, okay? So when we draw a sign diagram, all it's going to be is going to be a number line, essentially. The horizontal line there, okay? And then here's the big part in your notes. This is what you need to know, okay? We're going to find critical values, all right? Sometimes we'll call those CVs. We're going to find critical values, all right? There are two types of critical values. One type of critical value are x-intercepts, okay? Or roots or zeros, okay? That's one type. There's another type of critical value where the graph is undefined. So that's the second type. So we have two types of critical values. X-intercepts and where it's undefined. So what we'll do is we'll find those critical values. We'll put those critical values on our number line, wherever those critical values fall, whatever numbers they are. And then we're going to test around those critical values. So we'll pick numbers in between. We did a little bit of this last year, all right? So we'll test, and then we'll pick a number here, we'll test it. Say that it's a positive number, pick a number there, it's positive, pick a number there, it's negative. This is the reason it's called a sign chart, is because we're putting positive and negative signs on the chart. Okay? It's very inventive, very creative. Okay? So we're going to do this. We're going to do a couple sign charts today with some quadratics. And then I'm going to use it for another application that'll be on your homework. Okay? I'm going to scroll up a little bit. If you don't have that quite yet, we can go back and get a little bit. Okay? So the first one, it actually may help you a little bit on your test as well, may help review some things. If I'm going to draw a sign diagram for this, I need to find critical values, which means I need to find x-intercepts. All right? So how are you going to start that if we're looking for x-intercept? Thank you. Plug in 0 for y. So we're going to do that first. And then, how do we find this? Hopefully we can do what? Hopefully it factors. If it doesn't factor, go quadratic formula, go use your calculator. All right? What two numbers multiply for -2 and add for 1? -1 and what? +2. Okay? -1 and +2. And then I'm going to put that on my number line. I'm going to put those two values. Now, what two values are going to go on my number line? What are the actual x-intercepts? What are the roots? 1 and -2. Okay, bless you. Okay? 1 and -2 go on my number line. Everybody okay so far? Have we done anything new? Not really, right? Now, we're going to test this. We're going to test around these two critical values. All the way. You might go, well, Coach, you haven't talked about this, all right? So we've done x-intercepts. We've put them on there. Tell me about a parabola. Where is a quadratic undefined?
Does it touch the x-intercepts?
At the vertex? Not quite. And that's a good thought, though. When is there any value for x I can't plug in and find a point on a parabola? What's the domain? All real numbers, right? So are there any undefineds here? There's not. So what's that saying is this. We could have critical values all just x-intercepts and no undefineds. That's okay. We could have all undefines and no x-intercepts. That's a different type of function we'll talk about next week. Or we could have a mixture. We could have some of those and some of these. Okay? But in this situation, all we do is have a critical value that are x-intercepts. And there they are. Okay? Now I'm going to test them. What values, what numbers would you use to test this number line? What's one of the easiest numbers to plug in? 0. Where would 0 test? In the middle. 0 go in the middle, it test in the middle. What can I pick to test the right hand side? 2, 3, 4, 5, whatever you want. I like as small numbers as possible. Alright, and same thing on the left. -2, -4, -5. Could you use decimals to test if you like? Sure, I'm not gonna pick that unless I have to. Okay? Now, I'm gonna take those and plug those in. I'm gonna do the middle one first. So I'm gonna take 0 and plug it in. Well, what does that really give me? The y-intercept, correct? Alright, 0, 0 gives me -2. I'm not worried about the 2 part. All I'm worried about is the negative part. That's negative right there. Okay? When I take the 2 and I plug it in, 2 squared is 4 plus 2 minus 2. The 2 2's cancel, leaves me 4. I'm not really worried about the 4, I'm worried about positive 4. This is positive right there. Okay? And then I'm going to do the other one. I'm going to do -3, plug it in. So -3 squared is 9. Minus 3 minus 2. So that would be 9 minus 5, which is 4 as well. But it's a positive 4, so I have that there. Okay? This is why it's called a sign chart, because I have positive and negative signs on my chart. Okay? So what does that mean? Where's that going? Well, this sign chart tells me when I'm above or below the x-axis. That's what it's telling me. When is this graph above the x-axis? When is it below the x-axis? And so if I'm looking here, we could put our critical values on our graph. So 1 and -2. This is a positive number here, which means it's above the x-axis. This is a positive number over here, which means it's above the x-axis. This is a negative number in the middle, which means it's below the x-axis. Some of you going, well, why would you graph it that way when we just know what the parabola is? We can go do that, okay? Because I'm trying to build small with you. I'm trying to see how it connects here. That way when we have a little bit more complex function, we can use the above and the below axis so that we know where that graph's going. Because some of them get a little tricky. Okay? Now, the other application for this. What if I had this problem right here? Okay? Got a quadratic inequality. So where is this parabola greater than 0? So we could do the same thing that we just did. We found the roots, put them on our number line, we put them here, all right? Where is this greater than 0, which I'm saying, where is this a positive number? All right, well, where am I a positive number? Over on this side here, and over on this side here. So we would say, to answer that problem, -infinity to -2, and 1 to infinity. So our sign charts or sign diagrams can help us to solve inequalities. What if I flipped the symbol over? What if I took this and made it a less than? Now I'm looking for the negative, right? Which would be the ones in the middle. -2 to 1. Everybody okay with that? Let's try another one. So we're going to do this one right here. We're going to do this one right here, and then we'll be finished, and I'm going to let you have time to finish the test. Okay? What do you notice about this one? I'll give you a chance to copy it down if you haven't already copied it down. So y equals -2 x minus 1 squared. What format of a parabola is that?
Root form.
Close.
Vertex form?
I would say it's vertex form right now. Now I can get the root form pretty quick though, here in a second. All right? So I have that there. So what is my vertex? 1, 0, right? And so I could graph that pretty quick. I could say 1, 0 is here, and then it's concave down, and we're there. Now, before I get that, I want to do kind of more what we've been talking about. We want to find critical values, which are x-intercepts. So if I set this problem equal to 0, could you solve that? divide by -2, take the square root, move the 1 over, all right, you'd have it, bless you, okay? Is that the same equation? Except now it's what? Now it's in root form. Tell me about the roots. They're the same. They're identical. It's the same root twice. So it is 1 is what it is. So my critical value in this case is 1. It only has one critical value. It's still a parabola. The domain's all real numbers, so it's not undefined. It only has one critical value. What number are you going to pick to test? 2 and 0 is probably what I would test. Now, I'm going to shortcut this a little bit. Because here's the thing that you don't like about these problems. I can tell you because I don't like them either. Because you got to take the numbers and plug it in, test it, take another number, plug it in, test it, and that just gets repetitive, right? Take whatever x you want, plug it into there, in the box right there. What kind of answer are you going to get? Say again? Positive number. Why? Because we're squaring it. Pick whatever number you want. If I square it, negative times negative is positive. Positive times positive, positive. So this is always going to be positive. Well, if I take an always positive number times -2, what am I going to get?
Always negative.
Always negative. So we said a while ago, our parabola started there and it's going below, which our sign diagram proves the same thing. It's always in the negative. It's always below the x-axis. Okay? Now, again, I probably wouldn't draw a sign diagram to just graph a parabola in general, just kind of connecting it with you. But it is helpful for me if I ask this question. If I said -2x minus 1 squared, where is it less than 0? If I did an inequality. When is it? Everywhere? It is. Everywhere except that one point, right? So this would be all real numbers except for 1. All real numbers except for 1. Or you could write it from -infinity to 1 and 1 to, to infinity. So I write it like that. Either of those two ways would be fine for me. Okay? How about the answer to that inequality? Not quite. Because what are you thinking? It's got an equal to on it. So, where is it positive? Never. So this would be no solution in this case. Where are my sign charts positive? There's not a spot on them. Okay? So you see how sign charts can help us graph a parabola, and you're going, I probably don't need that a lot. But sign charts can also help us with quadratic inequalities. And that's what page 172 is about tonight. That's your homework, okay? You have like 4 days to do that because we won't meet again until Tuesday. We have a nice 3-day weekend, okay? And so here's what we're going to do at this point in time, all right? If you're done with your test, by the way, I'm going to give the test back to everyone, okay? Whether you finished or not yesterday. If you finish, you can look over it again real quick, turn it back in, that's fine, okay? All right? If you didn't finish, continue working. But when you're complete with your test, you have page 172 that you can work on as homework. So we can stay busy because we are in a testing setting, so I didn't need to be quiet. Everybody good?